In the Miocene, extremely interesting events took place. The climate changed so quickly that the animals had to literally sit on their suitcases. Most animals preferred warm habitats. When cold came on a certain territory, the migration of heat-loving animals became especially intense. The inhabitants of the Miocene made long journeys and invaded lands with a temperate warm climate. And local animals had to deal with uninvited guests. There were constant skirmishes for a real place under the sun. And the former owners had to leave their habitat and look for a new home. Some animals went to the territories from which the invaders came to them. There was a kind of animal exchange. Such large-scale migration influenced the serious and rapid evolution of many groups of mammals in the Miocene. At the end of the early Miocene, for the first time after a long period of mutual isolation, there was a significant exchange between Africa and Eurasia. The main effect of this exchange was the change in the African fauna. Cats, dogs, martens, rhinos, calicotheres, and pigs appeared in its composition. Probably at the same time, proboscideans emigrated from Africa to the Indian subcontinent. The first mastodons settled in Europe and North Asia in the early Miocene. At the same time, Ankytheria immigrated to Eurasia from North America. The most significant event in the history of the early Miocene rodents of Europe was the immigration of Asiatic hamsters, which no longer differed in appearance from modern descendants. In the Miocene, the first bovids and giraffes entered Africa from Eurasia. Miocene. This is the time of extinction of creodonts. However, in Asia in the Middle Miocene, two genera are still present. The largest representative of the Proviverinae, Dysopsilus, is the size of a modern jackal, and a very large representative of the Hyenodontinae, Hyanaileros, which was the size of a tiger. It is interesting to note that both of these genera are common in Asia and Africa, and Hyanaileros hyanailer is also present in Europe. This confirms the exchange of creodont fauna between Asia and Africa through Europe in the Oligocene. The ethological features of the group probably contributed to the extinction of the creodonts. The consequence of this is an increase in control over spontaneous activity and aggression. This large predator was less aggressive than modern large representatives of the carnivore order Carnivora. An ecological corridor has formed through Asia Minor, the Middle East and northern Arabia to Afghanistan and China. This is what scientists call the unusual process of animal migration. The main animal exchanges between Eurasia and Africa pass through this corridor. The most rapid evolution of the most diverse groups is taking place. Hedgehogs, shrews, moles, pikas, squirrels, jerboas, hamsters, and numerous subspecies. Also, hyperevolution did not pass by various types of primates, rhinos, ruminants, proboscis, mustelids, dogs, hyenas, cats, and other animals. The Miocene can rightly be considered an epoch of great diversity of animal species, in the formation of which one of the leading roles belonged to the territory of Asia. The spread of the steppes and the gradual disappearance of forests in the Miocene strongly influenced the growth of the populations of herbivorous mammals. Fewer trees, less energy, which is so necessary for any animal. Imagine for a moment an ordinary tree. It spends most of its energy on creating a support for itself. To this end, the tree develops a special solid trunk and many branches. In a temperate climate, animals can consume only a very small part of the edible substance produced by a tree in a year. On deciduous trees, leaves generally grow for only 6 months of the year, and fruits and seeds, with the exception of nuts, appear for only a few weeks. This means that temperate forests can feed only a limited number of animals in a year. The sharp increase in the amount of grass on land in the Miocene epoch meant, in fact, the emergence of a fundamentally new source of food. However, at first, it was not easy for herbivorous mammals to use the resources of this bottomless pantry. Some animal species even became extinct because they could not adapt to a herbal diet. Mammals, whose teeth were designed for chewing soft leaves, found it difficult to switch to such a tough and fibrous food as grass. For such animals, the herbal diet meant constantly increased chewing, and the teeth of herbivores quickly wore out, creating serious problems for these animals. After all, mammals do not have an unlimited supply of teeth, and toothless jaws mean inevitable starvation for them. Despite all this, in the Miocene, mammals became much more numerous and diverse. Many herbivorous species of animals arose. By this time, the ruminant stomach has become an ideal mechanism for digesting grass. As a result, a kind of explosion took place in the Miocene, giving rise to new species of herbivores capable of chewing gum. Ruminants can fill their bellies with a huge amount of food, which can be digested later. Moreover, if a predator attacks a ruminant, it can run away from it, taking with it a supply of food for several days in advance. Once in safety, the animal can, without too much haste, digest the food it has eaten. During this kind of ruminant revolution, the number of ancestors of the current antelope, buffalo, deer, giraffe, and sheep has increased dramatically. When Antarctica and Australia separated, a new ocean current formed that swept the entire world. Known as the Antarctic Circumpolar Current, it has caused global climate change and a massive upsurge of deep-sea nutrients. At the same time, kelp forests began to spread around the world. The oceans were primed for a rapid increase in biodiversity, and among this explosion of life were marine mammals. First of all, these were baleen whales. These whales appeared about 34 million years ago. But this was the first time that many new species appeared. There were over 20 different genera of baleen whales in the Miocene compared to today's 6. It was also the first time that whales began to increase in size, with some species reaching lengths of over 10 meters. 1. Balaenoptera subaldina may even have rivaled the modern blue whale in size, although scientists have not yet reached a definitive conclusion. Toothed whales also became much more numerous at this time. One line even became the top predator of the oceans along with sharks. These were macroraptorial sperm whales. There were many species, and all of these sperm whales were adapted to hunt other marine mammals rather than small prey such as fish, squid, or plankton. The teeth were huge, conical in shape, and the jaws could open very wide. The jaw muscles were obviously very strong, which gave even more bite force. The largest of all these hypercarnivorous sperm whales was Livyatan melvillei, perhaps the largest active predator ever. The whale could reach 17.5 meters in length. Each of the teeth was 30 centimeters long. These are the largest teeth, apart from tusks, in an animal that has ever existed. Being such a massive animal, the ancient sperm whale could probably prey on just about anything, including other whales. Leviathan's main competitor was probably Otodus megalodon, an incredibly hyped shark of comparable size in modern popular culture. Giant sharks flourished in the Miocene for the same reasons as marine mammals, and the megalodon was the largest of these animals. Another Miocene sperm whale, much smaller and less well known, is Rhaphacedus. Rathacetus had a very long, slender beak jaw, filled with rows of tiny teeth adapted for quick capture of fish. In fact, the predator was like a sperm whale trying to become a river dolphin. Since we are talking about dolphins, some of them also decided to get into the cohort of super large animals. Among the squalodons there were various species, some the size of a modern killer whale, but much more toothy. Initially, when squalodons were discovered, these predators were mistaken for dinosaurs, and they got their name because of the shark-like teeth. At that time, there were many families of toothed whales that are now extinct, including the antecedents. Perhaps the strangest Miocene cetaceans were the odobenocetopsids, with fragile crocodile snouts. One genus in this group, Odobenistops, had a bizarre pair of asymmetrical tusks protruding backwards from a broad muzzle. It may have been sensory organs, as these tusks were probably too fragile for actual combat. Odobenistops had powerful lip muscles, but nothing like teeth, other than tusks. This indicates that they fed by sucking food by picking mollusks from the seabed, like a walrus. And that's just cetaceans. During the Miocene, the evolution of pinnipeds, seals and their relatives, accelerated. At the beginning of the era, most of them were semi-aquatic creatures similar to otters, and by the end they already resembled modern species. One of these early, primitive pinniped relatives was Calpanomos. It was built like a bear and was originally related to raccoons, but it turned out that it was actually the predecessor of seals. The huge neck muscles and strong molars of Calpanomos indicate that it was a specialized eater of hard-shelled mollusks and similar foods, so it was very similar to a giant sea otter. As pinnipeds evolved, they became more and more like their descendants today. A new family of desmatophosids has evolved, related to modern walruses and sea lions. The largest species, Alodesmus, was a large animal, about 2.5 meters long. What's really interesting about Alodesma? If you look at the cross-section of the teeth, you can see the peculiar growth rings at regular intervals. This is presumably due to the fact that the males stayed on the beach during the mating season to protect their harem of females. During this time, they did not go to sea in search of food, so their teeth did not wear down at all. In the end, the groups of pinnipeds known to us today appeared odobenids, walruses, otariids, eared seals, and phocids, real seals. The walrus family was particularly diverse at that time, with at least 18 species, as opposed to one today. The largest of these was the formidable Pontolus magnus. With an estimated weight of up to 4,000 kilograms, this beast was the size of an Asian elephant and is undoubtedly one of the largest predators that has ever existed. For greater intimidation, he had 4 tusks instead of 2. Another genus, Pelagiarctos, had a similar build but was not as large. At the opposite end of the spectrum was the adorable Nanodobenus, the smallest member of the walrus family known. About 1.5 meters long, and it didn't even have tusks. Then came the otariids, represented today by sea lions and fur seals. They were not as diverse as the Miocene odobenids, but there were some very interesting species among them. For example, Thalassolian was huge, the size of a modern walrus. He lived in California. Oddly enough, Thalassolian literally translates to sea lion even though it was a fur seal. It is believed that this is the direct ancestor of the northern fur seal, an ancient species that arose in the subsequent geological period, the Pliocene, and still exists. Finally, real seals from the Phocidae family appeared. They differ from other pinnipeds mainly in the absence of external ears. One of the interesting genera was Prepusa. It is possibly the smallest marine mammal ever to have existed, measuring around 60 centimeters in length. There were quite a few species, one in what is now the Netherlands and several in Central and Eastern Europe. At that time, the last region was the bottom of a huge inland sea Paratethys, the last remnants of which today are the Black and Caspian Seas. The second genus is Hadrochirus, which is larger and not as harmless. Found on the Pacific coast of South America, it was related to modern Antarctic seals such as the leopard seal. Reached about 2.5 meters in length, and the jaws had strong teeth, ideal for chewing solid food. It may have gnawed on mollusk shells or even bones. The Thalassocnus sloth was ideally adapted to a semi-aquatic lifestyle. With dense bones and a long, beaver-like tail, as well as strong jaws for eating seagrass. However, on land, this animal was clumsy, because it had weak neck muscles, since it spent most of its time with its head on the seabed and fragile legs. Like hippos, it probably grazed in shallow water. Modern three-toed sloths are quite closely related to Thalassocnus, and are also surprisingly good swimmers. Finally, a few words should be said about otters. Like every other group of animals in the Miocene, these guys also suddenly grew huge. The largest member of the mustelid family in history was the Miocene otter, Anhydriodon, which is estimated to have weighed a staggering 200 kilograms. This lion-sized beast was technically not a marine mammal, as it lived in the freshwater lakes and swamps of Ethiopia. Strong, crushing teeth indicate that it ate a lot of solid food, perhaps turtles, crocodiles, armored catfish, bivalves, and the like. At the same time, he may have hunted terrestrial animals. A close relative, Inhydrotherium, also grew very large and could be found in what would become Mexico and the southern United States. Siamogale lived in the wetlands of China and Thailand. Its weight is estimated at about 50 kilograms, which is comparable to the weight of an adult wolf. The great thing about all the animals featured is that it's only a small part of what makes the Miocene era unique, because at the same time you had a lot of giant sharks and penguins. The first pastures, megafauna on land, a huge number of mega-animals in the Amazon basin and throughout South America, dominated by reptiles rather than mammals. Antelope-like pronghorns lived in North America. The bizarre horns of these animals grew right on the tip of the nose. Throughout the Miocene, horses continued to increase in size. Merygippus was the size of a pony today. The middle toe on each foot was disproportionately large compared to the same toe of its predecessors, and it can be said that Merygippus walked on tiptoe all his life, or rather, did not walk, but ran very quickly. Numerous tubercles on the molars helped him chew tough grass. Previously, horses were forest dwellers and ate tender and juicy foliage. However, by the beginning of the Miocene they had adapted to life on the open plains. Now elephants have become much more similar to their modern representatives. Mastodon. Scientists call this animal by another name, Platybelodon or spade tusk. The animal could make its way through the thickets like a heavy bulldozer. From the lower jaw protruded wide spade-shaped fangs, with which the animal dug various plants from the soil. Deinotherium was much larger than Mastodon. With the curved fangs of his lower jaw, he may have pried at the edible roots like a large pitchfork. We can get some idea of the Miocene ecosystem if we turn to its modern counterpart, the East African savannas. The grassy plain provides different types of food for a variety of animals. In the savannas of East Africa, zebras nibble at the rough tops of grasses, and wildebeests nibble at their leafy central parts. Gazelles, on the other hand, look for protein-rich seeds and shoots near the ground. Warthogs often kneel to reach the shortest grass or dig up edible bulbs and tubers from the ground. There are also herbivores in the savannas, who find food above the level of the tallest grasses. For example, a black rhinoceros eats tree bark, thin branches and foliage, but an elephant eats both grass and tree leaves, often absorbing up to 250 kilograms of vegetation per day. Well, growth allows the giraffe to avoid any kind of competition, since this animal can cut off branches and foliage at a height of 6 meters from the ground. Thus, different types of herbivorous animals do not claim each other's food resources, and there is enough food for everyone. Perhaps it was the same during the Miocene. Different species existed at the expense of different parts of the ecosystem. In the same period, other new settlers appeared. At the beginning of the Miocene, the ranks of birds were replenished with new species of parrots, pelicans, pigeons, and woodpeckers. A little later, the first ravens and falcons joined them. New mammals such as mice, rats, guinea pigs, and porcupines evolved rapidly. A strange group of horse-like animals also appeared, Chalicotheria. With large claws resembling hooves, they dug up edible roots. From now on, animals could move freely from Africa to Europe or Asia and vice versa. A kind of two-way traffic soon emerged, with elephants migrating from Africa to Eurasia and North America, while cats, buffaloes, giraffes, and pigs traveled in the opposite direction. The first primates were small animals, similar to shrews. Primates appeared on Earth about 65 million years ago. Evolution continued to work in this direction, and by the middle of the Oligocene, two main groups of primates had formed. New World monkeys in South America and Old World monkeys in Africa and Asia. Soon another group of monkeys descended from the African branch, which became the ancestor of the great apes and, ultimately, humans. The brain of great apes is larger than that of their other relatives. In addition, primates do not have a tail, and long and strong arms are perfectly adapted for climbing trees and jumping from branch to branch. The fossil remains of a small anthropoid ape, which they called Egyptopithecus, Egyptian monkey, fell into the hands of scientists. This monkey lived in Africa during the Oligocene era, about 27 million years ago. No one can say with certainty that it was Egyptopithecus who was the ancestor of modern great apes, but this is not at all excluded. Shortly after the beginning of the Miocene, about 24 million years ago, another, more highly developed great ape appeared, Dryopithecus, similar to the current chimpanzees. These animals quickly moved from their African homeland, through land bridges to Europe and Asia. Apparently, Dryopithecus walked on two legs, but ran and climbed trees with the help of all four limbs. Perhaps the primate even carried food in his hands. So, the history of mankind was about to begin. Thank you for watching this episode to the end. Put your finger up and leave comments. Subscribe and do not forget to click on the bell so as not to miss new and interesting videos from the Real Unreal channel.